students, this is impact testing machine which is used to test the strength of the aggregate against impact. This machine has the hard base of 30 centimeter diameter, and there are holes provided on it so that it can be fixed to the floor. There is a cup at the base which is having 102 millimeter of diameter, and the depth of the cup is 50 millimeter. Then there are two steel guide rails of hard steel, so that when you give the impact, raise the hammer and it falls, it glides through these guiding rails, and such that this hammer exactly falls on the aggregate. These two handles are provided here so that it can be lifted and it is allowed to fall under the gravity. The height of fall from the base of the hammer to the top of the aggregate is 380 millimeter plus minus 0.5 millimeter. This thickness of the rammer plate is 50 millimeter and base is 100 millimeter, and its corner is chamfered for 2 millimeter. There is no sharp edge is not provided here, so there is a chamfer here. Okay, you can see here there is a chamfer. So this chamfer is of 2 millimeter. Then before you raise, you have to insert the locking pin in this so that it will be held in this position. This height can be adjusted with the help of this knob, as you can see here, and counter is provided at the top. So every time when you raise and falls, counter increases by 1, and this is how you can get the number of times, how many number of times the weight is falling, that you can count. Apart from that machine, certain other equipment apparatus is required for this particular experiment. As you can see here, these GI sieves are there of size 12.5 millimeter, 10 millimeter, and at the base there is a pan which is required to prepare the sample, and at the end of experiment we are required to sieve this through 2.36 millimeter, and whatever is after sieving collected in the pan, that is weighed, and percentage of that is calculated with respect to original weight of the sample. So that will give us impact value. Apart from that, this is a tamping rod. So when we are placing the aggregate in this metal measure, has 75 millimeter diameter and 50 millimeter depth, and then aggregate is placed in 3 layers and it is stamped with the help of this stamping rod, which is having 230 millimeter length and the diameter is 10 millimeter. Electronic balance of capacity up to 30 kg and least count is 0.01 gram is also used for this experiment. This aggregate is kept in the oven at a temperature of 100 to 105 degrees Celsius for about 4 hours, and thereafter it is taken out and kept in the air for air drying. Aggregate is then sieved through these two sieves, 12.5 mm and 10 mm, such that the material passing 12.5 mm and retaining on 10 mm is to be taken. Look at the way in which it chooses to be rotated. See, this is the material which has passed 12.5 millimeter, and this particular sieve is 10 millimeter sieve. So this is the material retaining on 10 millimeter which we are going to take as a sample for our experiment. Initially, the empty mass of the metal measure is to be taken. 876 grams is the mass of empty metal measure. Fill the metal measure in 3 layers and tamp every layer 25 times uniformly by rotating the position of the rod, so that only at one place you will not compact it. Then after that you have to just level it with the rod itself, as you can see here. And make it flush with the top of the metal measure. Extra material you have to remove. Now the material compacted in the cup is to be transferred in the cup at the base of the machine. And once again you have to tamp it. Lifting pin to be removed, and these clamps are to be tightened. Fifteen blows are to be given to the material, and then it is to be lifted again, and the locking pin is to be inserted. So that it will not fall. After giving 15 blows and tamping it, then you have to remove the clamps and take out the cup, the base, and put the material, compacted material, on the 2.36 millimeter sieve. And then sieving is carried out. See, clockwise and anti-clockwise you have to rotate it as you are observing. You should not rotate it in only in one direction. Then the material passing you need to take for taking the weight. Note down the empty mass of the tray, which is 377 grams. Now, after the sieved material is placed in the tray, please note down the weight. It is 416 grams. Now let us see the calculations for aggregate impact value. The sample calculations are as under: mass of empty measuring cylinder is 876 grams. Mass of measuring cylinder plus aggregate is 1215 grams. Therefore, mass of aggregate filling the measuring cylinder is 369 grams. Then mass of empty tray is 376 grams. Mass of tray plus mass of material passing 2.36 mm size IS sieve is 416 grams, and therefore mass of material passing 2.36 mm IS sieve is 40 grams. Therefore, the impact value is 40 divided by 369 into 100, that is 10.84%. Then there should be at least two calculations, two determinations. So the readings are entered in the table, and then the average of the two values of aggregate impact value is taken, which in this case is 11.11 percentage. The table shows us the values and their classifications, or where this material can be used. So we can write the following conclusions with the interpretation of the results: that the given aggregate material is strong, because as we are observing here, it is between 10 to 20%. It can be used as a road surfacing material.